A bond is a debt-based financial instrument that corporations or government entities can use to raise money. It is essentially a standardized loan that has fixed interest payments, which the entity can offer to the public. The public can then buy as many bonds as they like from the pool that the entity is issuing. By paying for the bond, the public is essentially loaning the entity money. In exchange, the entity makes interest payments to the public, which are based on the par value of the bond. At the end of the bond's life, called its maturity date, the entity will buy back the bond by paying the par value of the loan. So, from the buyer's perspective, the cash inflows are the interest payments, which are called coupon payments, and the payment of the par value of the bond, which is called the maturity payment. As with any financial instrument, the value of the bond today, which we denote V sub B, is simply the present value of all of its future cash flows, which again are just its coupon payments and the maturity payment. The coupon payments are based on the coupon rate. The coupon rate is multiplied by the par value to find the coupon payments. Usually the coupon rate is given annually, but often the coupon payments are made semi-annually. In this case, we would just divide the annual payments by 2 to find what the actual coupon payments are. The bond itself has a required rate of return, denoted R sub D for the return on debt. That is different from the coupon rate. The rate of return is what we will use to discount the cash flows in order to find the value of the bond. So, it is also sometimes referred to as the discount rate. So the coupon rate is used to determine the coupon payments, and the return on debt, the required rate of return, or the discount rate, is used to find the present value of all of those future cash flows of the bond. Let's look at an example. Suppose a firm is issuing a bond with a par value of $1,000 and a semi-annual coupon rate of 8%. The bond has a length to maturity of 6 years. If the nominal annual discount rate is 7%, what is the current price of the bond? The price of the bond is equal to the present value of all of its cash flows. The coupon payment, remember, is the coupon rate, which in this case is 8%, times the par value of the bond, which is $1,000. And since the coupons are semi-annual, we can divide those by 2, and we find that every 6 months a coupon payment of $40 is made. So we enter that in for our payment function. The nominal discount rate every 6 months is 7% given the annual divided by 2, which is 3.5%. So again, we have to match the interest rates with the payment period, and since our coupon payments are being made every 6 months, we need to find the nominal 6-month interest rate, and this is exactly how we do this. Notice that we just had to divide this 7% by 2 because the 7% was given as the nominal annual discount rate. If we had started with the effective annual discount rate, we would have had to find the nominal discount rate every 6 months using geometric compounding. So basically we would add the effective annual rate to 1 and raise it to the 1/2 power and then subtract that 1. Make sure you practice that concept in the old test questions. So there are 12 6-month periods until maturity, and again the periods are 6 months, so we have to treat all of the periods and all of our time value of money functions as 6 months. So for n, it's a 6-year bond with 12 6-month periods, so we enter in 12 for the function n. The par value of the bond is $1,000, so 6 years from now, the entity, the firm, will be paying us $1,000, the bondholders. So the future value of the bond is $1,000. And notice that the payment is positive. It's a $40 cash inflow every 6 months, and the future value is positive. It's a $1,000 inflow at the end of the bond's life. And when we're doing bond valuation, these two numbers need to be the same sign because they're all coming to the investor. They're all going from the firm to the holder of the bond. We can now solve for the present value, and we're going to get a negative number for the present value. I've just written as a positive number as to represent what we're willing to pay for this bond today, and it's $1,048.32. Your calculator will again tell you a negative number for that present value, but if the question is asking what's the price of it, it's obviously going to be a positive number for price. Just know that when you're finding these different values in your calculator, the payment and the future value have to be the same sign, which is going to be opposite from what the present value sign is. So in the last example, we had a coupon rate of 4% and a discount rate of 3.5%, and that was every 6 months. And we found that the price of our bond was greater than its par value. We can generalize these results. If the discount rate, the return on debt, is greater than the coupon rate of the bond, then we're going to get a price today of the bond that's less than the par value. If the discount rate is less than the coupon rate, we're going to get a current price today that's greater than the par value. And if the return on debt, the discount rate, is equal to the coupon rate, the price today of the bond is going to be exactly equal to its par value. Now, it may seem strange that as the required rate of return increases, the present value of the bond decreases. So why is this the case? Well, the reason for this is because the required rate of return is from the investor's perspective. As it increases, the investor demands more return for his money. Since the coupon payments and the maturity from a bond are fixed, the only way for him to earn more on his money is to pay less today. And so sometimes we call bonds fixed income securities for this reason. The coupon payment and the par value payment, the cash inflows to the investor, are specified at the beginning of the bond's life. They're written out in the contract and they're not going to change. They're fixed. And so if the investor has a change in his required rate of return, the only way he can get more for that same amount, for that same fixed payments, those same fixed coupon payments and the same fixed maturity payment, is to pay less up front for the bond today. And that's exactly why we see this inverse relationship between the required rate of return and the value of the bond today, the price.